Hello everyone. In this presentation, we are going to experiment how to work with electrically erasable programmable read-only memory in the VA microsystem kit. The electrically erasable programmable read-only memory is available in this VA microsystem kit, and the data which is written into this EEPROM is 5501010101, which is getting displayed in the LEDs. How to check whether the EEPROM is working or not? The nature of electrically erasable programmable read-only memory is, even though there is an absence of power supply, it will retain the data. So the data is 55. Now I am going to switch off the power. Yes, power is switched off. And we are expecting the value 01010101. That is 55, the value which has to be retained in the EEPROM. When I switch on, the code is returned in such a way that it can read the EEPROM data and display in the LED. So when I switch on, the data is read from the EEPROM, and then we are able to see 55, which is getting displayed in the LED, which is alternate LEDs are glowing. 0101, 0101 is the LED which you are able to see it in this LED. So this justifies, so there is absence of power supply, as well as when the power supply comes, the 55 is retained. So this justifies an EEPROM is working. Now let us look at the circuit diagram of this. So with respect to the VA microsystem user manual, the EEPROM which is used is 24LS256. EEPROM which is used is 24LS256. So 2 denotes it is read-only memory, 4 denotes it is EEPROM, and 256 means 256 kilobits or 32 kilobytes. So this is a serial EEPROM, that's why serial clock and serial data. So there is an I2C based serial EEPROM is available here, and the address of this EEPROM is A2. I2C address is A2 for writing the data and A3 for reading the data, as we see in the user manual of VA microsystem kit. We have written a code for writing the data as well as for reading the data. So for example, for writing the code, we have written the value 55. So I am going to show you the data write. So this is the code. Let me show you. So I am going to demonstrate one more data which we are going to write in the live. So I am adding the EEPROM write code. Now I am adding the EEPROM write code. Instead of 55, we are going to write some other data to it. Instead of 55, we are writing some other data into it. Some other data means we can say it is C3, 0xC3. C3 means what? MSB2 LEDs will go and LSB2 LEDs will go. So this is the data we are going to write into EEPROM. So after compiling and building, I am downloading this. Downloading this means what? I am writing into EEPROM. Say for example, here you can see the EEPROM address is A2, and we are transmitting the start. This is I2C start, and A2 means device address. 00 is MSB address. This 00 is LSB address. So we are writing into 00's memory location of EEPROM with an I2C address of A2, and the content which is being written is C3. Content which is written is C3, that is data which is written is C3. So we are compiling and building, and we are downloading this code into the kit, which is writing the value C3 to the electrically erasable programmable read-only memory. Okay. So now the code is downloaded and the code is written. So code is written. And to justify that, the code is written now. Now we are going to execute the another code. Now we are going to execute the read code, reading from EEPROM. We are going to execute the reading from EEPROM code. I am going to add the EEPROM read code. EEPROM road. So C3 is the value which has been written. Now EEPROM code means what? We are going to use the same address A2, and we are going to write the starting address, that is starting address of the memory MSB00, LSB00, and then we are going to stop. This is dummy write. So writing the 0000 address to the A2 device is being done here, and then the current address read, I2C current address read is happening here. The current address read is from the device A3 is being done, and we are reading the address to the variable X, and that X variable is converted to the Y variable, and it is left shifted 24 times and given to the port 1 pin where the LEDs are connected in this VA microsystem kit. So this is the small summary. I am just compiling this and we are downloading this kit. By downloading this kit, what do you understand? And this code will read the data from EEPROM and then display it in the 8 LEDs. This is the code for reading the data from the EEPROM and displaying it in the LEDs of the VA microsystem kit. Now the code has been downloaded, and then we are going to check whether C3 is coming or not. If you look at the LED, LED shows C3. What is C3? 1100 and 0011. So this is the data which was read from the EEPROM. How to justify that? I am powering off. Even though there is no power supply, EEPROM should retain the value C3. After some time, when the power is switched on, we are able to see C3 is coming. This C3, the absence of power supply, C3 is stored. In the presence of power supply, C3 is read from the EEPROM and then displayed in the LED. This justifies EEPROM in the LPC2148 VA microsystem kit is working. Thank you.